useful for us. So today I'm going to talk about anisotropic conducting films. If any of you know, then it will be a recap type. Otherwise, I will explain what is this. So every day we use any of the electronic gadgets like mobile laptops or television. Maybe you are watching Zoom team meeting, and that's also must be either in laptop or in mobile or tablet. So every single day we are going through these electronic gadgets, and maybe we are not thinking about a very specific phenomena which is happening here. All these panels, either they are LCD panels or they are LED panels or AMOLED LED panels. So there are so many LED arrays which are arranged in such a manner that we can see a picture, a dynamic picture, which we see as a video. So how these LED arrays, which are so cost compacted and in such a tiny space they are situated. So how we are connecting these LED panels through the our PCB board or the electronic circuits, that's a very interesting phenomena which happens, and in engineering point of view, it is very interesting. So if you think about that there are so many, maybe hundreds or thousands of LED arrays are present in our laptops or in LCD panels. So this is a simple picture of a LCD panel, which we see in the display boards where only 100 of LED arrays are there. And we have a very tiny plastic or a rubber ribbon where electronic wires are going on through the circuit board to the LED panel. So in this picture, we can see that only 15 to 20 arrays are there. So it's easy to solder to directly to the circuit board. But think about a panel of a mobile screen. In mobile screen, either we have a LED display or LCD display, liquid crystal display. There are thousands of LED arrays in column and a row, and we need it to connect through the circuit board with this tiny ribbon. So this cannot be done with our conventional methods. If we want to connect these panels, you see a black screen, not the LED screen, because there is a polarizer above the LED arrays. Or if we are having a touch panel like a mobile phone or iPad, then there is a polarizer plus a touch panel. So you cannot see the LED arrays, but there is a thousands of LEDs embedded under that panel, which is somehow connected to the circuit board through which they are getting the electronic power. If we remove the polarizer, we can see that there are so many lines, maybe in thousands in the number, and we need these LED panels to be powered through the electronic circuit. And you can see this is the connection through the ribbon strip to the LED panel, and this is hardly 2 centimeters, because this panel is already only 1.5 inch, which you can see. This is a zoomed version of that picture, and in a 1.5 inch panel, we can see that there are hundreds of lines or thousands of lines. So it is very complicated when we want to connect these metal contacts through the circuit board. So what are the options we have present in the recent circuit PCB board connections, which we do in our day-to-day life? Either we can solder the components to the PCB board, or if the connections are very tiny, or we have some limitations of thermal instability, we use silver paste. Or if there is a problem with the adhesion, it's very tough to use the silver paste has a limitation that it cannot have a very good contact with. So we use a epoxy type conductive method. But all these three methods have their limitations. Like if we are using soldering, soldering happens by the fusion, means the solder iron and that material which we use for the solder, they fuse together and they join the wire through the PCB board. In silver paste, we have a liquid which will spread due to its nature, and same happens with the epoxy. So all these methods have their limitations. We cannot use in everywhere. And if we think about a PCB board, These connections which we are connecting through the PCB board, they can be soldered because we have enough space. But when we see this ribbon strip, which is having a conducting films or the lines, and this side is going to the LCD panel. This is very thin, and with the conventional soldering method, we cannot use because it's a plastic. We cannot solder it, and the lines are so close packed that we cannot use the silver paste also. If we think that okay, we can make a very small point and we can use the silver paste, still if we think about the commercial production, it is very complicated because the robotic arms move so fast that using a liquid paste or using a epoxy is not such efficient, and in such a broad manner we cannot use these three methods. So now what is the solution? The solution is actually quite easy. It's very easy in a way that we can think that how it will go to happen. But technologically, if we think how those materials are prepared, which I am going to explain, they are very, it's like a miracle in technology. So we call it anisotropic conducting tapes. This tape you can see, it's a very thin, maybe 10 mm or 20 mm width tape. It's a conducting anisotropic conducting tapes, but it's not a normal tape. It's not a normal conducting type tape. This is a picture of a single layer of that tape, which I have shown. It's over a aluminum plate. So there are two types of conducting tapes. One is like the first picture. This is a copper conducting tapes. In the copper conducting tapes, the conduction happens in all the three directions. But if you think about the anisotropic conducting tapes, the conduction happens only in one direction. So the conduction happens only in the Z direction. It means the thinnest dimension of the tape. And in the X and Y direction, there is no conduction. Means
Nikhil,
the electricity.
Nikhil,
Yes, sir.
what is that anisotropic conducting is made of?
That I will explain, sir, later.
Achha.
For broader picture, I will tell that whatever you see this white layer now, this is a non-conducting resin, or we can say a polymer stripe. This is a non-conducting material, and in between some nanoparticles are there which are conducting in nature. Okay. And I will explain how will they work. So moreover, if you will say that maximum part is non-conducting, but there are nanoparticles which are conducting. So somehow they are giving a situation where the conduction is happening only in the Z direction. It means in the direction where the tape is thinnest, and in the XY direction there is no conduction. So electricity will not flow in the XY direction. It will flow only in the width direction, means in the thickness direction. But if we think about the copper tape, it conducts in all the direction, bottom to top, XY direction, Z direction, all the three direction it conducts. So if we think in a symmetry diagram, this is the anisotropic conducting tape. This you see a white part and these green balls. This is our anisotropic conducting tape. The top one is the PCB board, or you can see the ribbon which having the these contacts, these four contacts. I have shown only the four contacts for a simple picture. This is the glass substrate or our LCD panel, and these are closely packed terminals. So what happens? This is the thickness I am showing. This is a cross-sectional view of the tape. So this white part is a polymer matrix which is non-conducting. In that matrix, they have embedded these conducting spheres. These green balls are the conducting spheres. You can see this is a real picture of that sphere, and this one is a specific nickel-coated sphere. Generally, these spheres can either be coated with the gold or they are coated with the nickel. So what happens when you press the circuit board side ribbon tape on the glass substrate? These conducting sphere will be pressed between these contacts, and they will supply, or they will make a conducting contact between the component RCB ribbon tape and the glass substrate. But where there is a gap, there is a spherical, these conducting spheres are there, but they are not connecting directly. They are there, but because they are in a gap, there is no connection in the Z direction. So if you see The only direction where the conduction is happening is Z direction. This is a full contact where the connection is there and the electricity can pass. The balls are here, but the connection is not there. So in the gap where there is no terminal, there is no connection. So if somehow you will see in X direction, there is no connection. In the Y direction, there is no electricity flowing. Only in Z direction, the connection is there. So these conducting nanoparticles are giving the contacts only between the terminal. They are not giving the contacts between the gaps. So the condition is these nanoparticles should have the dimensions less than the gap between the terminals, the gap between these contacts which are there either in the glass substrate or in our ribbon strip. So this is a symmetric picture. Yes, sir.
Yeah. So what is the size of these yellow strips or yellow parts?
Generally, these yellow parts, which are a gold thin films on our glass slides, are having 10 micron to 60 micron maximum. Means in our mobile phones and in our laptops, they are having this dimension. In calculators or a not that much resolution picture, they may have 100 microns or 200 microns.
Okay.
And these nanoparticles are in nanometers.
So what is the best we can do? Like how much can we reduce the size of this yellow part?
This yellow part we can go means to the minimum 10 micron or 100 of nanometers, because these particles are 60 to 10 nanometers, very tiny spheres are. I will show the picture, the real picture, then we can imagine what is the real ratio of these particles and the contact.
And there's one more question. So since it is glass in the bottom, so how will it conduct electricity from? So how will the electricity conduct? Because
so
glass
there
is a bad conductor of electricity.
No, this is a substrate, sir. On the substrate, we have LED panels, and through the LED panels, these are the contacts which are showing the golden color. I am saying this is the substrate. On above that, we have painted the thin film of conducting layer.
Okay, so this yellow
these yellow lines, these yellow parts on the back, they are going through these LED arrays. They are connected to these LED arrays. This glass substrate is just a, I should say the where the LEDs are embedded.
Yeah, so it's not a part of the anisotropic tape.
It's not. No, anisotropic tape is only white part, sir. This white part and this green sphere. That's only the my conducting tape. Anisotropic conducting tape. This green part is our touch panel or the LCD panel of mobile or whatever component. This component, this is the ribbon from the circuit board.
Mm-hmm. So the sphere, this yellow part and this white part is the anisotropic tape.
This is the anisotropic tape.
Okay.
And these yellow parts are not a part of the tape. We press it so hard that it will embed inside the tape. So these spheres are crushed. That I will show in the next slide in the real picture.
Sure. Got it.
Okay.
And
so
then
this
question. There is one more question. Can you please go back?
Yes, sir.
So what is the density of the spheres that we need to keep inside the that anisotropic tape?
Sorry, sir.
Because if the density is too much, it seems a sort of wastage, because we can sort of decide some optimum number of spheres so that the so because we want the conduction to happen at specific points only, right?
Yes.
So then we don't have to put so many spheres inside the anisotropic tape.
That's true. These companies must be doing some, because these commercially prepared tapes, so they must be giving some parameter that how many spheres are there in per square.
Okay.
Micron. Means this information I don't have, but they must have some criteria and different tapes must be present.
Sure. Okay, got it. Okay, you may proceed, brother, please.
Okay. So this is a real picture of a anisotropic tape. So this is a top view. So you can see these white dots. These white dots are actually the conducting nanospheres, and this part somehow is distorted due to the pressure or somebody has scratched it. This is the part of the, and this is the non-conducting part, the polymer part or the non-conducting matrix. If we see, This is the part of a real contact by the LCD panel and the ribbon, and you can see these black spheres are the our nanosphere, the conducting nanospheres. So this is the top view. This is how it looks when we see from the top, and this is the picture with the contacts. These are the contacts which we want to join with the bottom part. This yellow part is the in-between part, which is the tape. The bottom is not visible. This is the top part, which we can see the contacts are there. If we see a zoomed picture, then we can see this is a cross-sectional view. This part is the contact through your stripe. These are the contacts. This you can see this white picture is this contact. These spheres are crushed between the bottom contact of the LCD panel and the top contact from the ribbon. So these spheres are not participating in the contact because they are in between, and these nanoparticles, the sphere, are crushed between two terminals, between two contacts. So they are giving the contact between the two terminals. So this part you see, this is a gray part, is the adhesive contacting tape, anisotropic conducting tape, and these are the terminals. This terminal through the LED panel, and this terminal to the ribbon tape, which you can see here. So this is the cross-sectional view of the contact. So this was the whole picture of that scenario, that how we are connecting our ribbon from the circuit board to the LCD panel with that simple method, with the anisotropic conducting tape, in which only in Z direction the conduction is happening, and in XY plane there is nothing happening. And it is very easy to use it commercially, because you simply cut and paste the tape on the LCD panel. Then you can put our ribbon over that. You give a little bit thermal pressing, and these contacts, the two top and bottom contact, will crush the nano conducting spheres, and it will start giving contacts between the two terminals. So this is how we are giving the connections to our LCD panels in the circuit board. And I have seen the video from the YouTube, from this channel, which has explained very nicely. And this channel has other schematic diagrams also. So I will give a special thanks to this channel and this video. And thank you.